state Graham's law of diffusion. So what does Graham's law of diffusion state? So this is the third law, whereby the first law that we discussed the Boyle's law. It states that volume is inversely proportional to pressure when the temperature is kept constant. And then as you can see, that was the formula for Boyle's law. And then after Boyle's law, we went to Charles' law and said that Charles' law, it states that volume is directly proportional to the temperature if the pressure is kept constant. And as you can see, that was the formula of the Charles' law. And after that, we also went to the third law, whereby now the fourth law is Graham's law of diffusion, which states that the rate of diffusion of any given gas is inversely proportional to the square root of its density if the pressure and the temperature will be maintained constant. So that is what Graham's law of diffusion states. So it states that the rate of diffusion of any given gas is inversely proportional to the square root of its own density if the pressure and the temperature is maintained constant. So part B was asking 400 centimeters cubed of nitrogen gas. So take note, this is nitrogen gas, not nitrogen atom. So 400 centimeters cubed of nitrogen gas diffused through a porous plug in 120 seconds. How long will it take 360 centimeters cubed of oxygen gas to diffuse under the same conditions? So 400 centimeters cubed diffuses through a porous plug in 120 seconds. How long will it take 360 centimeters cubed of oxygen gas to diffuse under the same conditions? So here, first of all, what you must take note is that we have nitrogen gas having its own mass. We have oxygen gas having its own mass. So here we see that the mass of nitrogen is 28 grams. Nitrogen gas means that we have two nitrogen atoms. So one nitrogen atom is 14 grams, the other nitrogen atom is 14 grams. So if you add these two, you're going to get the total mass of nitrogen gas is 28 grams. So for oxygen, on the other hand, is a denser gas which is heavier than nitrogen. So one oxygen atom is 16 grams, the other one is 16 grams. Therefore, the mass of oxygen gas is 32 grams. So here, since we are being asked about the time, we are going to use the formula of time. So for the formula of time here, we're going to say the time of the first gas to diffuse divided by the time of the second gas to diffuse is equals to the square root of the mass of the first gas to diffuse divided by the square root of the second gas to diffuse. So in this case, the first gas to diffuse is nitrogen. The second gas that you have been asked is oxygen. So substituting on the formula, we're going to say the time of nitrogen gas divided by the time of oxygen gas is equal to the square root of the molecular mass of nitrogen divided by the square root of molecular mass of oxygen. So in this case, we have been given that the time of nitrogen is 120 centimeters, which is 400 centimeters cubed. Here, it's 400 centimeters cubed. For oxygen, we have not been given the time of oxygen, but we have been told that oxygen is 360 centimeters cubed. So if you have been brought in such a situation, the first thing and the most important thing you do is that bring nitrogen to the same level of oxygen. That is always the first thing to do. So the gas that you have not been given the time, like in this case, you have not been given the time of oxygen. So nitrogen, we have the time. So bring nitrogen to the level of the oxygen in terms of volume. Nitrogen is 400 centimeters cubed at 120 seconds. What if nitrogen was 360 seconds? So that is what you should ask yourself. If nitrogen was 360 seconds, how much time will it have diffused? So what we are going to do here, we are going to say that 400 centimeters cubed of nitrogen takes 120 seconds. What about 360 centimeters cubed of nitrogen gas, not oxygen? Let's bring nitrogen to the level of oxygen in terms of volume. So if 400 centimeters cubed of nitrogen takes 120 seconds, how about 360 centimeters cubed of nitrogen gas? So how long will 360 centimeters cubed of nitrogen gas take? So we're going to do that cross multiplication, and if you cross multiply it correctly, you're going to get 108 seconds. So 360 centimeters cubed of nitrogen is going to take exactly 108 seconds to diffuse through that same porous plug. So now we have the time for nitrogen under the 360 centimeters cubed. So since we have now these values, so we are just going to continue now with the formula. So the formula, remember, it was the time of nitrogen gas divided by the time of oxygen is equal to the square root of the molecular mass of nitrogen gas divided by the square root of molecular mass of oxygen gas. Now let's substitute everything. So the time here for nitrogen under the same level of oxygen 360, so we are going to say 108 seconds divided by the time taken for oxygen. It's equal to the square root of the molecular mass of nitrogen, which is 28, divided by the square root of molecular mass of oxygen, which is 32 grams. So if you do all these calculations correctly, you're going to get 115.976. So the time taken for oxygen therefore will be 115.976 seconds, and that is correct. So that is the time which oxygen will take to diffuse, or rather that is the time whereby 360 centimeters cubed of oxygen is going to take to diffuse through the same porous plug, the same as nitrogen. So apart from that, you can also use the formula for rate to calculate the time which oxygen is going to diffuse through the same porous plug. And to calculate the rate of diffusion of a substance, we see that the rate is always equal to the volume divided by the time taken by a certain gas. So in this case, we have been given all the values of nitrogen gas, whereby the values of nitrogen gas, we have the volume is 400 centimeters cubed and the time is 120 seconds. So we already have these values, whereby having these values, it can now be easy to calculate the rate by which nitrogen is diffusing. So if we divide 400 centimeters cubed divided by 120 seconds, so we're going to get nitrogen diffuses 3.3 seconds, 3.3 centimeters cubed per second through that porous plug. So that is the rate whereby nitrogen is diffusing through that porous plug. So we have 3.3 centimeters cubed per second. So after that, we are going to employ now the formula for calculating the rate of diffusion according to Graham law of diffusion. Thereby, the first gas to diffuse, remember we have nitrogen. The second gas to diffuse, remember we have oxygen gas. So here, what we are going to do, we are going to use the formula of rate and say the rate of nitrogen gas divided by, which is the first gas, the rate of nitrogen gas divided by the rate of oxygen gas is equal to the square root of the molecular mass of oxygen gas divided by the square root of molecular mass of nitrogen gas. So remember, the formula for calculating time is direct: nitrogen, nitrogen, oxygen, oxygen. But now the formula for calculating the rate, this other side is inverse. Like whereby we do this, the first gas over the second gas is equal to the square root of the molecular mass of the first gas, of the second gas rather, divided by the square root of the molecular mass of the second gas, as per the definition of the rate of diffusion of Graham law of diffusion. So here we have the rate of nitrogen gas divided by the rate of oxygen gas is equal to the square root of the molecular mass of oxygen gas divided by the square root of molecular mass of nitrogen gas. So here we have already found that the rate of nitrogen gas is equal, the rate of nitrogen gas is equal to 3.3 centimeters cubed per second. Oxygen gas, we have not been given the rate. So the second step, or the next step that we are going to do, since we have the rate, so we are going to do this. We are going to substitute everything in our equation and say that 3.3 centimeters cubed per second for nitrogen over the rate of oxygen gas is equal to the square root of oxygen gas mass, which is the square root of 32 grams divided by the square root of 28 grams. So if you do this calculation correctly, you're going to get that the rate of oxygen gas, is equals to 3.087 centimeters cubed per second. So that is the rate of oxygen gas that you have calculated here. So that is the rate, remember that. And also remember, how do we find the rate? So like as we are beginning, we say that the formula for calculating the rate is equals to, so the rate is equals to the volume divided by the time. So that is the formula for calculating the rate. So in this case, we already have the rate of oxygen gas, whereby the rate is 3.087 centimeters cubed per second. So let's substitute everything to the formula for calculating the rate and say that 3.087 centimeters cubed per second is equals to 360 divided by x. So the x is represented by the time, whereby we should calculate this time for oxygen to diffuse. So this time, if we do everything correctly, we should get that the rate is 116.247. So 116.247 is now the time whereby oxygen will diffuse through that porous plug. So let's look at the first equation. So the first method that we did using the time, we got 115.9. So this other one, we are getting 116.2. So if we round everything off, both of the times we are going to get, both of the times is 116, whereby we are still correct. So if you use this formula or the formula for rate, you are still going to get everything correctly. So you should take note, because sometimes the question may ask, use the formula of rate to calculate the time. Or the question sometimes may ask, use the formula of time to calculate the time for that gas. So you should know, and you should be in a best position to use both formulas to calculate the time if you have been asked to use this formula or that other formula to calculate what you have been asked.